Okay, so the first thing that we have to learn for this quiz is how to find a basis from a spanning set of a subspace. So first off, a spanning set is something that looks like this. So we say span of a bunch of vectors. So we have like v1 and v2 or something, and probably more. Okay. Also, the snoring is Peanut. Hi, Peanut. Okay. So we have some vectors, and we're spanning them. So what does span actually mean? Well, span, we're going to take all possible linear combinations. Well, it's probably important to know what a linear combination is, right? A linear combination is just multiply by scalars and add. So whenever we hear linear, we're going to think about multiplying by scalars and then add. The adding part is the combination part. So we're going to get into like linear transformations and shit like that. And the linear, it just means that nothing is raised to a power. None of our elements are being multiplied by other elements. It's just scalars and then we're adding. Okay, so the span of these vectors is just all possible linear combinations. So I can write this span as A times V1 plus B times V2 plus ... all the way up for A, B, all the other constants we have. There's some real numbers, so there's some constants. And V1 and V2 are in the set. That should be listed somewhere, but so V1, whatever. It's fine. You understand. Okay? So now we have this spanning set, right? But we want a basis. So what's a basis? Well, a basis is a linearly independent spanning set. Well, we already have the fact that it's spanning from up here, so we're good. So now we just have to make sure they're linearly independent. So what do? Well, we just throw them in a matrix. So we have V1, V2 as the next column, V3, etc. And if I'm checking for independence, I want to row reduce. Okay, so any column that would be a free variable. So what is a free variable? That just means that the column doesn't have a leading one. Okay, so any column that results in a free variable, these are going to be the dependent rows. Or excuse me, dependent vectors. So that means we can just go ahead and ignore them. So all of the columns that have a leading one, those guys are going into our span. Or excuse me, not into our span, into our basis. Okay, so to recap, how to find a basis from a spanning set for some subspace. Okay, so we've got some span, and this is a spanning set for a subspace. This is all one idea, okay? So we want to make sure, because we're taking all linear combinations, but we want a basis, we only want the independent guys. I'll leave this connection here of how the taking all linear combinations and finding the basis connects. I mean, the idea is that if it's in the span but it's dependent, then it's already in the span, so we don't really need it to keep making the span. The basis is just sort of like a small grouping, so a minimally small, so we couldn't remove one, that spans the set. Anyway, don't worry too hard about that. So we want to find a basis, so we need a linearly independent spanning set. We already have that it's a spanning set, right? It's already spanning. So now we just have to check the independence of these vectors. So throw them in a matrix and row reduce. So this is just saying that V1 is column 1, V2 is column 2, V3 is column 3. Any column that results in a free variable. So, for example, I might have a matrix that looks like this. So if I have a matrix that looks like this, notice that this column and this column both have free variables. So both of these two would be dependent, whereas these two vectors would be independent together. So they would form my basis. So then anyone that is independent, we're going to shove in our basis. So our basis is the set of all our independent V1, V2 from above.